Okay, so I'm filming a couple of videos just to sort of have that repetition of what the conversation we did in class. I'm talking about the example 10, and then what's the important part is first of all, once you read the question, I mean, you can see the answers there as well, but once you have the question, you just sort of get familiar with writing that part of the null form distribution, which is basically what your continuous random variable does. So I've already wrote it here that the x, which is like the a continuous random variable, follows the normal distribution. And let me write it again. So that's my continuous random variable, follows the normal distribution, and that's going to be inside. We want to put the mu and the sigma squared. So if we put the numbers, then we're going to end up with normal distribution, and then the mean is 39, and then the standard deviation is 6.1, but you are expected to write 6.1 squared, because essentially what we use inside the brackets is the mean and the variance, right, which is the standard deviation squared. So imagine that I could sort of draw a little shape and just draw the bell curve around the mean, which is 35, and I want the values that they go all the way up to 39. So let me just shade that area that we are calculating, which is what the calculator is going to do. And then on the left, I will run through the keystrokes on the calculator, so you see again how we're dealing with that. So you go into the menu, then you go into the probability, and then we go into distributions number 5, and then we want number 2, the normal CDF, which is the cumulative. That means it's going to start from a very, very, very small number all the way up to 39. Now, by default, the calculator has the lower boundary to be minus 9 times 10 to the power of 9999, essentially to represent the infinity. You can keep this number, or you can replace that number with a negative and then any big number. What's that? Like that's 100 million, right? Or you can put it like minus just 10,000. It doesn't really matter, because imagine that the distribution is normally distributed around 35, right? And we know that 3 standard deviations above and 3 standard deviations below, they will include the 99.7% of the observations. So the minus 10,000 is way far away, so it's enough for a lower boundary. Now, the first question is asking to calculate the find the probability that a trout caught in the fish farm is less than 35 centimeters. So the correct notation is the x smaller than 35, but still the upper boundary is going to be 35 because it's a continuous random variable. So it's not really making any sense for us to distinguish up to 34.9999999 or even include 35, because don't forget, it's an estimation of what we actually do, right? And then the mean is going to be 39, and then the standard deviation is going to be 6.1, and then we press OK, and then we have the answer here. You can see here that I've done it already twice, one with a negative 9 times 10 to the power of 999, and once with a negative 10,000, and it still got the same answer. And I'm sure, let's just try once more. Let's just make this one a minus 100, or minus 100 for a change, right? Just to see what the answer is going to be, and you see the answer is the same. And I really have to go to even small. Let's put minus 1. Let's see what the answer is going to be. And still the answer does not change. So I guess you get the idea. The lower boundary has to be low enough, but it doesn't have to be, negative infinity. Now, what would you write down? So what would make sense to write down is what you see on the calculator there. So put a normal CDF, and then feel free to put negative infinity if you want. It just doesn't really matter. 35, which is going to be the mean, 6.1, yes, 39, sorry, 35, which was the value, we want less than 35. Then we have the mean, which is 39. And then we have the standard deviation, which is 6.1. And then please do put the complete answer you have on your calculator, 0.255996. And then right underneath the approximation to 0.256, and then include 3 significant figures. And that's going to be the complete answer.